So dear viewers, today I am going to show the instantaneous war compensator. So in this part we will see the performance of the STATCOM in the open loop mode with RC load. Okay, so now first of all you can turn on the supply. Okay, turn on the connect the grid, connect the control unit. Okay, load unit. Okay, now turn on the supply first. Okay, we have at this time we have connected the CT and PT on the DSO, and we can observe the voltage and current. So at this time the water switch is on, so the voltage are there, but we have not connected yet the control or any load are there. Okay, so you can just see the current. Okay, we have only connected the load, so power factor is 1. Okay, now we will just change the mode to RC. Okay, so turn on the load, one load R, turn on the MCB first, then turn on the switch 1, then you can toggle to the RC load. Okay, then you can just turn on the this. Okay, now you can just see the power factor is now minus 0.95, and here you can observe the voltage and current. So now current is leading with the voltage. Okay, also you can increase the load and clearly see the leading current. Okay, so now you can just see I am increasing the load, so you can just see the current is lead with the reference of voltage, and the power factor is now minus 0.85. Okay, now we will turn on the control and compensate this current, and we can maintain the unity power factor at the source. Okay, now first of all you can turn off it. Okay, now you can just turn on the control by pressing this button, and you can just see the control is on. Okay, IQ L is 0.5, so we need to compensate with IQ. Okay, but with minus 5. Okay, so now you can just see the my control is on, but the power factor is poor still, 0.95, and also you can observe here the voltage and current. Okay, now we will add the minus Q value by pressing this decrease button. Okay, so I am adding the minus 5 compensation current. Okay, so here you can see the performance. So you can just see the power factor is now unity, and also you can see the voltage and current waveform. So almost the unity are there, voltage and current. Okay, now again I am increasing the load current. Okay, so by turning on this load, so I am increasing the load, so IQ L current is 1.5, so I want to increase this IQ command to 1.5. Okay, just wait. Okay, just you can just see my power factor is poor, 0.93, and you can just see the phase difference between voltage and current. Okay, now we can compensate it by adding the minus IQ. Okay, so I am adding the minus IQ to minus 1.5. okay, because the load current is 1.5. okay, so now you can just see IQ and IQR is matched with minus 1.5, IQL 1.4, and ID almost 0, VDC 200 volt. Both loads are on, and now yes, you can just see the power factor is 0.99, and also you can observe the voltage and current are in phase here. Okay, and also you can just observe the KVR var 0. Okay, KVA almost 0, KW 0. Okay, current 1.7. okay, voltage line to line phase voltage. Okay, so likewise this you can observe the parameter from here, this meter. Okay, now we will see the DAC values at control unit. Okay, so I have connected the DSO at the DAC point. Okay, So we have just seen the voltage and current. Okay, so my load is now RC load, so the current is now lagging. Okay, just so you can just observe the voltage and current waveform. So this is the voltage and the current is lag. Okay, and also you can just see when I'm removing this load and decreasing the IQ ref, so you can just see the current waveform. Okay, so IQL is 0.5, IQ and IQR is 1, now increase decrease, so minus 0.5. Okay, so almost unity power factor are there, and you can just see the voltage and current waveform, and also you can see the power factor is 0.99. Okay, so likewise this you can perform your practical in the open loop mode with RL and RC, and you can just observe the power factor at this meter, and also observe the voltage and current at these test points, and also you can observe the voltage and current at the deck side, and you can just verify your control. Okay, thank you.